Good morning, students. In today's class we are going to see what are the problem solving techniques in unit 1. Before going to discuss about the problem solving, we have to know according to what are goal based agents and what are the example problems techniques available in our problem solving scenario. So first of all, we have to know how the goal based agents are working. So how the goal should be achieved now, we have to frame the actions. So that is nothing but we have to create an environment which is ready to take an input, and we have to perform some operations. What are the resultant actions will be only helpful to reach to the goal state. In simple terminologies, we have to tell now, we have to set the initial state as input, and we have to perform some operators and operations on the by representing as actions, and then based on that actions only we are going to reach to the goal state. So here some of the example problems. Let us we discuss how we are going to frame the initial state and actions or operators, and how to reach to the goal state, how we are going to represent the goal based agents for these toy problems. And also we at the summary we also discuss what are the real world problems are existing in the problem solving techniques. Here it's one of the examples. Here it is 3x3 board. So initial state we have 3x3 board, and final state we have 3x3 board, and here we maintain on empty move an empty grid, which will be helpful to reach from initial state to the final state by performing some actions. Now we are going to see how we are going to write initial state, final state and goal state, and then what are the operations or actions going to perform for these problems. So here in this what is the state representation? So it's a 3x3 board, and what are the operators now? In which way we can move the grid? Either we can move from left to right. So here in this example we can move from here in this example we can move from left to right and right to left, up to down and down to up. It is the operations we are going to perform. And what is the initial state? We have initial state like this. It's consisting of 8 grids, and the same 8 grids we are going to represent in the goal state by reaching this arrangement. So in this way we are going to represent. Here see, it's a 3x3 array representation. Tiles on the boards and operators are left, right, up and down. So initial state is the configuration of the board, and final state is also the configuration of the board. So let us see another example. It's a 8 queens problem. Now you say what is the state representation for this 8 queens problems. So here it is a 8 cross 8 grid. So 8 cross 8 is now total is consisting of 64 squares. So 364 squares. And what is the initial state? Initial state, they place the queens at different columns and different it place the queens in the 8 cross grid 8 sorry they place the grid in 8 cross 8 chessboard. And what are the operators now? Whether we can, what are the rules when we are going to play chess for the queen? Whether we can move the queen from either horizontally, vertically or diagonally. Here what's the goal is, we have to place 8 queens of the chessboard such that no queens attack any other. So we have to place the queens in different rows and different columns, and also make sure that it does not diagonally intersect each other. So in which way we are going to frame the problem solving technique for the 8 queens problem. We are going to provide the solutions for the 8 queen problem. So next move to the missionaries and cannibals. So same scenario we are going to follow. So here 3 missionaries and 3 cannibals has to cross the river from one end to the another bank. So here the capacity of the boat is maximum capacity of the boat is 2. So here one condition they mentioned, if at any point of time the cannibals outnumber the missionaries on the either boat of the river. So in the cannibals count should not be more. So that is the condition when they cross from river, when all are cross the rivers safely. So now see, missionaries and cannibals moves, what is the goal here? Moves all missionaries and cannibals across the river safely. What is the constraint? So here the missionaries count can never be outnumbered by cannibals on either side of the river. So on both sides the missionaries count should not be outnumbered, means that should not be less than cannibals count. So here the state is configuration of missionaries and cannibals on and boat on each side. So what are the state represent? What is the environment present here? Is the state is nothing but what is the environment present here is, so it's a missionaries, cannibals and boat and the side on one side of the river. And then initial state we have 3 missionaries, 3 cannibals and the boat on the near bank. Same, what are the operators? So when what are the operators is nothing but here we need boat to cross from one end of another end by set of occupants. These are the operators we are going to use to solve these particular problems. Here initial setups we have 3 missionaries and 3 cannibals on bank of the river, and first side there is a there is no one is crossed at the initial state, and then first condition 2 cannibals is crossing from this bank of the river to the other end. And then the second condition, so the boat should not be empty when they are returning from first side to the near side. That's why it's dropped one cannibal here and it's returned back with another cannibals. Therefore the count should be 3 missionaries and 3 cannibals. So again it will be traveled to the another bank by 2 cannibals. So same mechanisms they followed here. So you observe that what's the thing they observed here is they maintain the conditions. The missionary number, the missionary count out will not be outnumbered when compared to cannibals. So by following that some conditions, and also another condition, the boat should not be empty then they retained or when they carry the person from one end to the another end. So finally we reached the destination by maintaining 3 missionaries and 3 cannibals safely reach to the destination. So same mechanisms. Here you have to put it in mind whenever you are traveling from one end to another end, the logic should be maintained in mind is the missionaries count should not be outnumbered when compared to cannibals count. So the boat should not be empty, the maximum capacity of the boat is 2. Maintaining that conditions in mind, we have to solve this problem. So here is a crypto-arithmetic problems. Here we are assigning the digits of 0 to 9 to numbers. So what is the logic behind it? How the problem solving techniques takes place here is when you perform any solution. So any solutions we have to provide the digits to the letters. That same digit number they will not be repeated to the for the 2 characters. For example, if I take S is 2 x is 3 means, so I won't repeat this 3 value to either E, N, D. So if for example if I take 4, E is 4 means that 4 value will not be repeated to S, N, D. Like that different digits should be takes place for different letters, and we have to find the solutions for these things. This purely based on logical thinking. So when we have performed, we have to frame the conditions like that. Now you tell what is the state for this mapping letters to digits is for our initial state representation, and initial state is empty mapping. So initially it does not map any digits to the letters. We are not mapping letters to the digits. It's initially it's in the form of in the representation of letters only, and after that we are assigning digit to a letter. For each and every letter present in the problem we are assigning a different digit. So unique digit we have to assign. So the same digit number we are not going to repeat for example same number will not be allocated to the 2 different alphabets. In this way we have to design the problem solution. So the goal state is after completed the things, the condition should be satisfied in the result. So main scenario, the main problem solving technique here is we have to mapping digits to the letters, and should be unique to each and every letters. The solution will also satisfy that condition. So removing 5 sticks, you have to frame the conditions. Here also what is the state initially we have a 5 sticks. We have to frame in initial state it's having the combination of 6 coins. So it should be remove exactly 5 sticks from this 3 5 sticks from this grid, and after that you have to frame exactly 3 squares. So in your state it is a combo collection of squares. Initial state we have 6 squares, and after that what are the operations we have to perform? We have to exactly remove the 5 sticks from the operators. In operator place we have to exactly remove 5 sticks, and in the goal state we have to form exactly 3 squares. Try it on your own ma. So again I will repeat the condition. In state we have 6 squares, and initial state we have 6 squares is a representation of squares, and initial states we have 6 squares. What are the operations we are going to perform now? We have exactly remove 5 sticks. On goal state what we have to form now? We have to form exactly 3 squares. In this way we are going to frame the goal based design for the remove 5 sticks problem. See, previously observed, I remove 5 sticks and form the 3 squares. So like that you have to write the state, initial state, operators and goal state on your own. So this is the solutions, and after that we are going to discuss about water jug problem. So here they are giving 2 jars. One is having the capacity of 5 gallon jug, and another is having 2 liters of capacity. Here what is the state? So 2 jugs. Here we have 2 jugs with one having capacity 5 and another one having capacity 2. So it's a water jug problem. So initial state that both are having 5 liters of water and 2 liters of water, so 2 different jugs. What are the operations we are going to perform to reach to the goal state now? Either we can what are the conditions we are going to consider here now? We can fill the jug 1, we can fill the jug 2, and we can empty the jug 1 and we can empty to the jug 2. We can transfer some water from jug 1 to jug 2 and jug 2 to jug 1, or we transfer entire water from jug 1 to jug 2 or jug 2 to jug 1. So based on that operations we have to measure exactly 1 gallon of water in 2 liters of jug. So our goal state is we have to calculate, we have to measure 2 gallons jug with exactly 1 gallon of water. So nothing but we have 5 and 2, we have performing some operations, and after that we have to without any measurements we have to fill this 2 gallon jug with 1 gallon of water. Now you understand, I think so you understand what's the conditions. So this is the way we are going to think. First I am going to empty 5 gallon jug and empty 2 gallon jug. So what we are going to do now, I am going to think in which way we are going to think. For example, if I empty 5 gallon jug and I pour water 2 gallon jug, so it's that 5 liters jug will occupy up to something. Again I will pour 2 liters of water. Now it have the capacity of 4 liters. Now if I pour again 2 liters means 1 liter only it will be occupied. So the totally 5 liters, and remaining 1 liter is stored in these 2 liters. I think so you people understand. First it is having we are going to empty this 5 liters and pour first time 2 liters, and again second time we pour 2 liters, and third time when you are pouring 2 liters it's having the capacity to store only 1 liter. Then 1 liter is poured into the 5 liters jug and remaining 1 liter is stored in the 2 gallon jug. So our condition is, our goal state is reached. In this way we are going to solve water jug problems. So some more real world problems are route findings. Route findings means to find the shortest path like Google Maps, and logistics and VLSI approach, robot navigations, in which direction the robot has to move, our automated missions and all. If you are going to consider the vacuum cleaner, is wherever the data is there it is going to clean based on mission modifications. Like learning platforms, we are going to apply this problem solving techniques. So thank you very much for your patience. Practice and learn how to think logically to solve a problems. So at the summary I am going to tell to you people, you just revise it how to represent the state, and how to design the initial state, or what is the initial state, and what are the operations you are going to perform in middle of goal based agent, and what is your goal state. So these things is enough when you solve a problem uh, in the real time environment, either to a human, either to a mission. First we have to define the problem. So define the problem is nothing but we have to represent the problems. We create a environment for that problem, and after creating the environment that problem, we have to understand what is the present scenario, that is initial state, and what are the things or the actions we are going to perform to reach to the goal state. That also we have to put it in mind. So what are the keywords we have to know? First you represent the state, and you have to understand what is the starting scenario, and what are the operations you are going to perform to reach to the goal state. So thank you very much, students. Thank you for your patience. I think you people understand, and follow thorough the examples and practice. If you have any doubts, we will discuss in the classroom.